In this video, we're going to talk about the particle nature of matter and how we classify matter into elements, compounds, and mixtures. The images and the examples are adapted from our Cognity IB higher level textbook for chemistry. So first of all, let's talk about states of matter. Earth is very special. Its conditions allow for the existence of water in all three states of matter. So it can exist as solid, so ice, liquid, and then also gas. So when our liquid water evaporates, it becomes a gas. So remember, solid means that it has a fixed volume and a fixed shape. Liquid means that it has a fixed volume but an unfixed shape. It'll take the shape of the container it is in. And then gas doesn't have a fixed volume or a fixed shape. There also is a fourth state of matter called plasma, which is an ionized gas, and that's very common in space. So state changes, that is one thing that you need to be able to talk about and to understand what each state change means. So changes of state can occur due to the changes in the temperature. And when we learn about gases, we can also learn that it can also be due to changes in pressure. So when we learn about gases, we'll learn that in higher altitudes, water actually boils at a lower temperature because of the change in pressure. There's less pressure in the upper atmosphere. So at constant pressure, if you're increasing the temperature, you're increasing the kinetic energy of the substance. So the particles are moving faster and the forces of attraction between the particles become reduced, and that allows for a change in state. And evaporation occurs at the surface of a liquid only and can occur actually below the boiling point. So that's why water can evaporate from a puddle even though it's not at the boiling point. So gas can become a solid through the process of deposition, and a solid can become a gas through the process of sublimation. We're more familiar with the other four terms. So melting is when the solid goes to a liquid, and freezing is when the liquid goes to a solid. Evaporation is when the liquid goes to a gas, and condensation is when the gas turns to a liquid. And we can also do something called a heating curve. So that shows the changes in temperature as a solid changes to a liquid and then to a gas. And you'll note that the temperature stays constant in the middle of a state change. So it's when you're melting ice to become water, there's a long period of time where the temperature is staying constant. And the same thing will happen. There'll be a sharp jump as it becomes a liquid. And then there's a long period of time when the temperature stays constant as the liquid goes to gas. So you are probably very familiar with the Celsius scale. It's based on the melting and the boiling points of water. So 0 degrees Celsius is the freezing point of water, and then 100 degrees Celsius is the boiling point of water. Kelvin, however, is based on the kinetic energy of the matter itself. So 0 Kelvin, which is absolute zero, is when matter has no kinetic energy. So the particles are not moving at all anymore. And the Kelvin temperature is directly proportional to the kinetic energy of the particles. So when we do a lot of our calculations in chemistry, we actually have to convert our Celsius temperature to Kelvin because we need it to be directly proportional, and the Celsius scale is not. So the Kelvin temperature is equal to the Celsius temperature plus 273.15. So at 0 degrees Celsius, the Kelvin temperature is 273.15. Density is probably something you dealt with before as well. That's the mass of a substance per unit volume. So density is equal to the mass divided by the volume. And because water has a density of 1 gram per milliliter, items with lower densities than that will float, and items with higher densities than that will sink. So now we'll look at matter itself. So elements, they're made up of one type of atom, and they can't be broken down into simpler forms. And when we learn about the periodic table, we'll learn that the elements in the periodic table are arranged by their atomic number, which is equal to the number of protons found in their nucleus. So hydrogen has 1, helium has 2, lithium has 3, beryllium 4, and so on. And elements can't be broken down into simpler forms, and still retain their same properties. You can split atoms, but now they don't have the same properties. Compounds, on the other hand, are made of 2 or more elements in a fixed ratio. Both elements and compounds are considered to be pure substances because they're made of elements, and elements are one type of atom, compounds are 2 or more atom types, but they're in a fixed ratio. So, for example, water, H2O, which is found down here, is an example of a compound. Sodium chloride is an example of an ionic compound. We'll learn about that. They actually form these lattices of interchanging ions, so in a 1-to-1 ratio. So sodium ions and chlorine ions forming this lattice structure. Compounds have unique properties from the elements that make them up. So water is always going to have the same properties. All water, sodium chloride has the same property no matter what sodium chloride particle you find. Now, mixtures, on the other hand, are made of 2 or more substances that are not chemically combined. So they're not found in fixed ratios, which means that they can be separated. And a little bit later in this little slideshow, we'll take a look at means of separating mixtures, because depending on their properties, you'll have to separate them in different ways. So again, there's 2 different types of mixtures. There's homogeneous or homogeneous mixtures and heterogeneous mixtures or heterogeneous mixtures. We'll talk about both of those. So a homogeneous mixture or homogeneous mixture, they're also called solutions. And in these mixtures, the particles blend together in one phase and they don't separate upon settling. So solutions include a solute dissolved in a solvent. We're going to learn more about that when we learn about our solutions unit. So another example of a solution or a homogeneous mixture is air. It's actually a mixture of many gases, and each one retains their own properties. So our atmosphere is made of about 78% nitrogen, almost 21% oxygen, 0.93% argon, 0.04% carbon dioxide. That's higher than it was less than a century ago. And that's we'll talk about when we talk about our concerns about climate change. And then other gases are about 0.13%. Now, a heterogeneous or heterogeneous mixture, the components are not uniformly mixed. So they could actually form layers, or you can see different particles mixed in the whole solution. So this is an example here of oil and water, but there are other types of mixtures like salt and pepper would be an example of another heterogeneous or heterogeneous mixture. So if you wanted to separate the particles in a mixture, you will have to apply various techniques, one of them being solvation, filtration, recrystallization, evaporation, distillation, and chromatography. Some of these might have to be used multiply to separate your particles, and we'll talk about those. So the first one is filtration, which is not spelled correctly, I see. That's used when one of the particles is insoluble in a solvent. So if you had like a mixture of sandy water, you could dissolve the mixture in a solvent, and maybe there's some salt mixed with the sand. The solution gets run through a filter, and the insoluble particles get left behind. So the salt water would go through, and the sand would stay up in the funnel in this example where there's some filter paper. Evaporation is used when a solute is dissolved in a solvent. So you just heat the solvent up and the solvent evaporates, but the solute will stay behind. So again, salt water could be then evaporated if you had separated originally the salt water from the sand. Solvation is used when one of the particles is insoluble in the solvent. So the mixture gets dissolved in the solvent, the solution gets evaporated, and the insoluble particles get left behind. Distillation is used when one part of the mixture has a lower boiling point. So you mix the mixture up in the distillation flask, which is this round bottom thing right here. And then the solution that has the lower boiling point will evaporate. and it'll enter the condenser, which is this thing here, and you're actually flowing water through here, so it makes it condense, and then the distillate will fall into this container, the second flask. Another fun technique is to use chromatography, and that's used to separate a mixture of solutes and a solvent. So one fun activity, which we'll do in class, is where we take a dab of black ink, we place it into, and it's water-soluble ink, we'll place it into a flask of water, and we'll allow that ink spot to be carried up the chromatography paper, and then the pigments will actually separate. It'll be quite interesting to see. Recrystallization can be used to remove impurities from a solid mixture. So in this example, you would dissolve the impure mixture in a small volume of hot solvent. You'll cover this flask with a watch glass to prevent evaporation and contamination. And you'll allow the solution to cool to room temperature, and then the crystals will begin to form. And then you put the flask in an ice bath to cool even further, and you'll filter the crystals by vacuum filtration, which is another fun technique you may get to use in university.